In this video, we will cover question number 2 and number 3 on this polynomial worksheet. So again, we have the factored form here. We are seeing something again. If you watched a previous video, I said that every single bit of this equation, they would mean something. Just make sure that you know what it means. Let's go ahead and take care of the roots first, since we have the factored form. So we have 5, so 5 right here, okay, with a multiplicity of 1. So that's easy, that's nice, meaning that when we graph our when we plot our graph, sketch our graph, the graph would just go straight through. Okay, which way would it go? I don't know yet, we'll find out. Okay, and then the next root, it's going to be well, 2x plus 1 equals to 0. So what would x be to make it 0? That would be a negative 1/2. Okay, if you put negative 1/2 into x, then you would have 2 times negative 1/2, which would be just negative 1. Negative 1 plus 1 would be 0. Okay, so you have negative 1/2, so somewhere right here. Okay, negative 1/2. Okay, negative 1/2 right here. Or maybe I write it down there. Okay, negative 1/2. This is 5. Okay, always have a good habit writing numbers just to help yourself and help others out as well. Now this is a double. This is a multiplicity of 2. That means we are going to see a bounds. So we can say this is a multiplicity of 2. Sometimes you may also hear that this is called a double root. Okay, meaning that it is the root twice because it's being squared. So we have to make sure that there would be some sort of bounds at negative 1/2. Is it bouncing on the positive side or negative side? Again, we don't know yet. We'll find out in a moment. Well, so next up, we will go ahead and find out our y-intercept. Our y-intercept would be to find out f of 0. F of 0 would be negative 0 minus 5, and then 2 times 0 plus 1. So that should be a negative 5. And then this is just 1 square, so it'll be just a number 5. So 5 right here. Okay. All right. Now, so far so good. Okay. We have the y-intercept, 0, comma 5. Okay. Now let's go ahead and find out the degree and the sign of leading coefficient. So again, from the first video of this series, I said that you may just go ahead and multiply the first term all together, just the first term in each parentheses. Okay, in each factor, just go ahead and multiply the first term. And make sure you also take care of the square if there's any, okay, or any kind of exponent. So what we're going to do here is this. We are going to multiply the negative with the x to the first power, and then 2x squared. Okay, so that would result in negative 4x cubed. The 4 comes from the 2 square, x cubed because you have x squared, and then you multiply by x again. The negative is the original negative that sits in the front. So we have a negative leading coefficient with a degree of 3. Okay, so like in the first video, we said that let's go ahead and use negative 10 and 10 just to, double check where it starts, where the point is. It's where the point is it on the positive side or the negative side? All right, so if you think about 10, negative 10, sorry, if you imagine negative 10 being x, multiplied by itself would be a negative number, but then there's also a negative that sits in front of it. So therefore, it will result in a positive number. So when it's negative 10, we are going to have a very, very positive big number when x is equal to negative 10. So we know it's going to be starting high. And then it's going to come down to the first root, which is 1/2, -1/2. As we said that it's going to exhibit some sort of bounds, and it does. So it's going to bounce. And then now, some of you is going to raise this concern sooner or later, which is how do you know where it's going to turn? Okay. Now, this is a polynomial function, not like a quadratic. If it's a quadratic, then we know where it's going to turn. It's going to be right in between the two roots. But it's polynomial, so it is not a guarantee that it's going to be exactly in the middle of those two roots, but it's going to be close enough. Okay, close enough. So if you make a turn somewhere between the two roots, we are happy. Okay, we are not going to find out where it's going to turn. That's for you to find out in calculus. Okay, but for now, we are very happy that if you can have something that is in between in between the two roots, then we're good. And then it's going to pass through x equals to 5 because it's just a single root, multiplicity of 1. So let me draw a better one right here. And now, does it make sense? Well, again, we are going to put positive 10 into the x. And just to see if we should get a negative number, well, 10 cubed, it's 10,000 times 4, it's 4,000 with a negative in front, just negative 4,000. That means when x is 10, we are going to have a y value of negative 4,000 for that particular point. So we'll say, yeah, we're supposed to end low. Okay, and it's also that since it's an odd number degree, the starting and the ending positions will be the opposite. Okay, so if it starts high, it will end low if the degree is odd, because well, that's what odd degree functions do, because when you plug in positive and negative numbers, they end up to be, quite the opposite. So that's for number 2. Again, make sure that you are aware of how the negative it's going to influence the graph. You also know that when you have a multiplicity of 2, how are you going to take care of it? So let's go ahead and switch gear to our next question. Now, the next question is also going to be very similar because it's also a degree of 3. But we're going to go step by step. Okay, first we take care of the roots. So this one, x is going to be 2. Okay, because 3 times 2 minus 6 will be 0. So we know our first root would be 2 with a multiplicity of 1. So just a normal single root. And then we have negative 2. That will be this one right here. This will be a double root. Okay, this will be a double root. That means we're expecting a little bounce. Let's go ahead and find out our y-intercept. Y-intercept would be here. So we have negative 6 times 4, which is negative 24. So somewhere right here, you go ahead and say this is negative 24. Okay. So degree, now let's go ahead and multiply the first term with the, and we take care of the exponent as well. So from here, we have x squared times 3x. So the first term is going to be 3x cubed. So the sign of the leading coefficient is positive. And then the degree, it's going to be 3. So if you think about it, if you have a negative 10 into 3x cubed, negative 10 being the x, so what kind of value would you get? You will get a very negative value. So that's how you know it starts low. It goes high and high. And then as it approaches to negative 2, this is where you have the double root, the multiplicity of 2. That's where it's going to bounce. And then it's going to turn, hit the y-axis, and then hits the x equals to 2, just passing through it normally. So if you can produce a graph that's just like this, you are perfect. You are perfect. And again, You do not need to worry about where the turning points are in regards to the y-intercept. If you say, can I turn before or after the y-intercept, or is it going to be a problem if I turn at the y-intercept? It's all good, okay? It's all good. We are not going to look into that. All we care is, do you start at the high, do you start and end at the proper location? Did you hit those particular x and y intercepts? And if you do, we're all happy. Okay.